Okay. So first of all, I don't know if you noticed it or not yet, but I know our last couple classes have been kind of weird. I know Annie appreciates that. We've been debugging her stuff. But so I went ahead, I gave everybody in class a free quiz for participation in that. So everybody has a free 100% in a quiz. You can see that on your grades. So thank you for that. I do promise you that the stuff we were doing is related to systems programming with the server stuff and that kind of stuff, but I know we went off script a little bit there. Just kind of what happens at the end of the semester, I suppose. Okay, so having said that, there was a request for me to go over what is going to be on the final sooner rather than later, so let's talk about that today for a little bit, and then if we have time, we'll talk about some new stuff, and then if you have questions or want me to review anything, we can do that on Friday, and then I'll talk about, maybe something else new to wrap things up. So I'm going to start off. Just out of curiosity, does the free quiz seem fair to everybody? That's a reasonable apology for taking class time.
I want 2 free quizzes.
Well, then you got to say it's not reasonable and whine more. Okay. But you got to mean it now. You've already nodded. So I try to be as fair as possible, but I know when you get to the end of senior seminar stuff, people get panicky, and you want to make sure that they can get stuff looking as good as possible. But I do promise you I helped most groups in the senior seminar. It wasn't just like Annie getting special treatment. If you came to me and asked for help, you got a lot of help, is the punchline. Where did we... I want to talk about the stuff since the midterm first, then go back to the beginning. We should have a slide in here somewhere that says midterm, right? Here we go. Okay, so this was solution to midterm stuff. All right, so then we talked about race conditions. So as usual, most of you have had my midterms before. Same format, 10 questions, 10 points per question. I'll design it for a normal class period, so it's designed to take 50 minutes. I'll give you a half hour to take it. You'll have the full 2 hours to take it, so there should not be any sort of time issue. I don't design it to be extra long or anything like that.
I heard a rumor that it was going to be on Blackboard.
No, that's just for my 300 class. Yeah. Because I'll be coming back from a conference the night before, and just in case my flight's delayed or something like that. It's a small class. Just do it on Blackboard so I don't stand up a final exam. But I'll be back for this one. When is our final?
Friday.
Oh, I'll easily. If I'm not back, I could probably walk and be back in time for this one. So no, it's in person. If I will offer this though, if I know when you have finals late in the week, if any of you want to take it earlier, as long as it's the earliest I want to give it to you is Wednesday, but if you really are really desperate, I can probably make earlier than that work, because that means I have to write it earlier than that.
Does that mean we all have to take it then?
No.
Oh.
So long, I'll have you swear on a Bible that you're not going to share what's on it to anybody else. But if it would help you from travel plans and stuff like that to not wait till Friday to take it, we could work something out. So just message me and we'll figure it out. I'll have you take it during one of my other sessions, or have you come in during a time, whatever. We'll figure it out. Whatever. That's cool with everybody? All right, so just let me know. I'll be as flexible as I can, but no, it's an in-person one. Okay, so since midterm, we talked quite a bit about race conditions, this whole idea of having a resource that's shared among multiple processes, multiple threads, whatever it is, that where you have this potential condition where two things try to grab the resource at the same time. So understand what a race condition is, for starters, and then we want to look at some of the ways we can combat race conditions. So this kind of thing, this was our kind of our shared memory example where we had a resource here in the middle that we were trying to protect, where we had possibly two child processes here. We did run into an issue when we're using fork with sockets, where you didn't have access to the network subsystem. But if you replace it with something else instead of sockets, the example would flow. It just happened to do with a network subsystem thing. So this idea of having shared memory being a resource that two people or more than two people are accessing at the same time, how do we protect that? So first of all, we were talking leading up to the midterm, we were talking about the idea of inter-process communication. So that was something that didn't really happen in a direct way before the midterm, right? So since the midterm, I think we mentioned shared memory before the midterm, but since the midterm, we talked about having something that's shared between multiple processes or multiple threads, things like that. Not even necessarily protecting it, just shared stuff. Okay. Before that, we were dealing with, and I'll flip back through those slides too, but we were dealing with really ways for things to communicate through normal channels. So sockets, I don't remember if we actually mentioned the word pipes or not, but pipes are effectively local sockets. We could think of them like that, although we use sockets locally, just pretended like these were machines on the internet in different places. It would be more resource friendly to use pipes if you're only talking with things locally, but they're effectively the same thing. So having shared resources opens us up to race conditions. It's kind of it's the gateway drug to race conditions. All right, so we have the shared memory thingy. So understand shared memory, understand the concept of race conditions. There will be quite a bit of programming on the exam, but I would say a lot of the programming is going to be more of C competency, where I'll have you write things that manipulate strings or build, pointers, maybe even something with linked lists, stuff like that we've done since the midterm, but really forcing you to come out of this class with the background in C programming, which is kind of your go-to language for any sort of systems programming stuff. Things that are specific to like shared memory or semaphores, that kind of stuff, I might put on there in terms of, I might give you some code and say, what does this do? Not that you shouldn't know how that stuff works, but if you had some documentation sitting in front of you, you could write that and then manipulate it. So on the exam itself, I'm really looking for competence. I'm looking for, can you translate your programming knowledge from the last 3 years, let's say, through the C language, which you focused on this semester, and turn it into solutions to problems, kind of proving that now you possess the skills in this language that could then be applied to the systems programming stuff. That makes sense? And then I'll ask you questions about the systems programming stuff at the high level, semaphores, shared memory, race conditions, threads, multiple processes through forks, things like that. And then I'll probably also have one or two questions where you have to look at this code and tell me what it does. What will the output of this be, or something like that. But most of the programming questions where you'll have to write code will be like array manipulation, string manipulation, write some logic that does something with, C. Maybe I'll provide you with a linked list and say, find the largest value in this linked list, forcing you to have to traverse it and that kind of stuff. So C programming skills applied to things that shouldn't necessarily be brand new concepts for you, that kind of thing. That makes sense? Go ahead.
So for like traversing linked lists, would we also have to write the helper functions, or would those be like?
I would probably give you a page. Like the intention for that would be being able to use something that's already been created. I wouldn't ask you to write the linked list. So I would either say, I'd either give you a linked list and say, use this as your starter, or assume there exists a linked list and make, I think I've asked questions like this before, make any reasonable assumption of functions that might exist. So in that last example, like it wouldn't be reasonable for you to have a linked list that already has a find max value, you know, but it would be reasonable for you to have one that maybe, you know, says get position or something like that, where you can get at bucket 0, get at bucket 1, get at bucket 2. That would be reasonable. You know, but not a function that already solves the question I'm asking you to solve. I get those pretty often. Where it gets really bad is in like Python, where if you've done much work in Python, Python has about 4 million functions that, like, anything that you think that should maybe exist almost does exist. So there'll be like something that a student will write down for an answer to the question. Like it's something I never introduced. So I have my catch-all. Like if we never introduced it, you can't use it, right? It's something that I'm not aware of. And then they'll come up and say, I typed this in and it works. And it totally does. Like what am I supposed to do with that? I don't know. I mean, some of them like almost seem made up. Like there's no way that function exists, and it just does. Something that you would never use. Like it was just some made-up problem for a test or something like that. It just exists as part of the language as a convenience function.
For example?
I'm trying. Let me see if I can come up with one quick. I don't want to spend too much time thinking about it, but I want to say that it might be something like. No, it wasn't that. I was thinking something like remove vowels. It's something along those lines where, you know, it makes sense to maybe have a function that you can pass in kind of a string or something and say remove all occurrences of any character in this. But it was something much more specific than that. You know, it really was something, it wasn't this specifically, but it was a function called like dot remove vowels. It was like the exact question I asked, but it's not something you would necessarily use. But it wasn't vowels, it was something else. It was just very strange. Almost felt like Visual Basic. How many of you have ever programmed in Visual Basic? Okay, so Visual Basic, I'm not a big fan of the language. I kind of almost view Visual Basic through the same lens as Python, although Python's much newer, where Visual Basic will let you like cast something to almost anything. Like you can turn a Boolean into an ice cream cone, and it will just figure out what that meant, maybe. Like it doesn't give you an error. It just works. I mean, it doesn't work in any sort of logical way, but it does something. I don't know. Does Visual Basic even still come with Visual Studio?
Yeah.
Yeah, that was
It's still a thing?
I don't think many people use it.
Well, it's not a bad tool for rapid application development stuff. I'm just not sure now that, I mean, the whole thing with Visual Basic early on was it allowed you to build your interfaces really quickly where you could just double click the buttons and stuff. But now that's true for any of the .NET languages. So I'm not sure the real benefit of Visual Basic anymore, because I actually feel like it's not really an easier language to learn because some of the rules are a little loosey-goosey. You know, just kind of lets you do some stuff that probably shouldn't let you do. It's inconsistent in some ways.
Wait, what class are you teaching Python in?
200 now.
200?
Yeah.
What
So,
changed?
well, every year I'm looking for like a new kind of low-code type tool, and then we kind of graduate into syntax. And this year I used Mendix as a low-code tool, which if you went to the senior seminar things yesterday, Caitlin Smith, her thing, did you think that her management tool actually looked pretty decent?
Yeah.
She did that all in Mendix. So that's writing almost zero syntax. She built that, and they host it and everything like that. So, and Mendix is kind of an enterprise level tool. You can talk to third-party APIs. I mean, so it's pretty impressive for many kinds of like web applications and stuff like that. You can do things pretty quickly. So I try to start off with something like that. I don't. When you guys had it, maybe it was Game Salad
Yeah, it was in
or Alice.
Block, like,
Blockly.
block league, and yeah, so something like that that makes you focus on the programming, problem-solving concepts, and then you graduate into, let's start now applying that to syntax. And we usually jump right into Java, I thought. So now we kind of get into Python earlier than we used to get into Java. Java was kind of almost like maybe the last month or even less than that of that class. So now we do Mendix for like the first 3 weeks or so, first 4 weeks, kind of parallel to when I'm doing the review stuff, like the history stuff. And then we jump into Python. So you're doing syntax, but even though all languages I feel are kind of the same, Python, you can kind of start doing stuff in a fairly friendly way with all this extra structure. You know, where Java, you have to have the public class and public static void main, just a lot of extra stuff that feels intimidating, where Python, you can just write a line, print hello world, and it prints hello world. So it gets them into the syntax quicker. Yeah.
Everything after Java still feels disappointing though, so probably good that you started with something else.
Why is that?
Best programming language.
Really?
Not to pull an Oscar, but
But you think everything after Java is disappointing? Well, so what else if you C Sharp, it's Java, same language, right?
still disappointing. I mean, like I think that
They
maybe I
gave
should
you
say-
pointers back.
Maybe I shouldn't say disappointing, but like uninteresting. I don't know. Like it doesn't do anything that I couldn't. I mean, I guess pointer syntax, sure.
Okay, and then you had Scheme, obviously the best language ever.
Assembly.
How many? All of you loved Scheme, right?
I mean, it was interesting, and I feel like I understand recursion a lot better. But
I really like fun
I don't
puzzles
know.
with it, but it's not something I'd ever want to actually develop in.
Yeah.
Really?
I don't think I'll ever.
We've had. I'm trying to think of the name of the student. Sam. He worked on the.
Miller.
Sam Miller, yeah. He's working for a place doing Scheme programming, making like bucks.
Isn't he at Northwestern?
I don't know where he's working, but I got a message from him last year sometime on Slack. I probably have it somewhere. I think I took a screenshot and sent it to Dr. Lockbear. Where he's like, I hated it when we wrote it, but I think he got a pretty, cushy offer writing Scheme. Now he's like, that was useful. Oh, Scheme's the best language. Swift's the same. Actually, I'm not that big of a fan of Swift, to be honest.
Really?
Yeah, I feel it's a pretty manipulative language. It was, when I teach it, I talk about, Apple kind of making a grab. Apple didn't make it for the Apple people. Apple people were happy with Objective-C. Mm-hmm. They're trying to pull people over from Java and Python over to the dark side, right? Mm-hmm. So the real issue I have with, how many of you have coded in Swift before? So an issue I have with Swift, and they're actually doing away with it, so they're kind of doing a bait and switch, is initially the language had like 30 different ways of doing the same stuff to try to mimic the different ways the folks were already used to in these other languages. And now as they've released new versions of Swift, they start pulling back some of those things to make it turn into a more structured, let's call it, C-like type thing. Swift still has that overall goal of minimizing the extraneous stuff you might type, and I'm okay with that. Don't type, if you always type the same thing, don't make you type it. I'm fine with that, but,
So,
I feel like it was a money grab, like good intention for the wrong reason, or good idea, but for the wrong reasons, something like that. Yeah.
So maybe part of the reason that I feel so strongly about that Java is my favorite language to write is that I like strongly typed languages. So then when I moved, I've done some Swift stuff, and then I moved to JavaScript, and I'm like, okay, I don't really like loosely typed languages. There's something wrong with them, but I prefer strongly typed languages.
I agree. I mean, I agree with that.
Yeah.
I like the structure, because then you're very, I'm a big fan of being very specific about what I want to do. And you see that when I always use this dot and stuff like that. So I like the defined structure of strongly typed languages. But it's not like that doesn't exist. One of the things I like about Python, and one of the reasons why it's actually such a good first programming language, is it forces indentation. So it requires you to write your code in a way that's readable. Otherwise, it just won't work. where the number of students that come to me with like broken Java programs where everything's left justified or on the same line or something like that, or using bad curly brace syntax like Emma. You're on the same line person, right? Yeah.
I
It's
got made fun of for going a new line at my internship.
these people.
Did you?
I switched.
No.
Oh yeah, I switched. I had to.
Yeah, my internship. Yeah.
Really?
Yeah.
They have guidelines for how you format your code.
It,
Gotta follow them.
It's just terrible.
okay, but yeah. So what I was gonna say was something that I can appreciate about Swift is that like there are certain, like you're saying that you don't like that about Swift, that certain things are optional and that you can do things different ways. But sometimes I appreciate that. I think that there's something cool to that, and that you can kind of do what you like. Sometimes.
Oh no, and I'm okay with that in principle. But the rationale for why they put it in there is the part I don't agree with. You know, if you're making a language to make life better for the people who are already writing stuff for iOS or whatever, I'm fine with that. But those people weren't complaining about Objective-C. This is a grab to get people to come over to the dark side, you know, which is fine, but it was for the wrong reasons, I guess. I don't know. It's more of a principle thing, maybe. But man, they complained about putting the curly brace in the. Oh, so much harder to read.
Went through code review and they were like, yeah, shouldn't do that. Like, okay.
Did they give you rationale other than just coding standards for them?
They just said like coding standards. This is the way that we do it, and we try to keep everything looking the same.
Yeah, I mean that's fair enough. There's a rationale for that.
Yeah.
Just I wonder why their coding standard isn't the other way.
Isn't it actually a thing that in certain languages they have different standards for where you would put a curly brace? Like I want to say that I was actually told there, but it was by another intern, so fact check me. But he was saying that I think in ABC Sharp you're supposed to put it on a new line according to their documentation, but in Java, in all their documentation, it's same line.
Yeah, I don't know. Swift, I think the default is next line. In fact, Swift might not let you put it on the same line. Fact check that, but
No, it does.
it lets you put it on the same line?
It does put it on the same line. I think that is the default too.
Oh, is it?
Yeah.
Oh, I'm thinking of what language automatically puts it down to the next line.
Another good argument that I've heard for putting it same line is that if you, in most IDEs, if you do like the generate autocode, like give me my getters and
Yeah.
setters, it's going to give it to you same line.
Yeah, I know, I hate that.
Most IDEs that you can set up.
Can you?
Yeah.
I haven't.
Yeah, but it's not the default. The default should be my way, and then you should be able to modify it to the Emma
Well,
solution.
Visual Studio, the default's your way.
Is it?
At least
Yeah.
for C Sharp.
Yeah, but then when I was getting made fun of for it too, I was like, well, I learned in CSC450 with Dr. Lippman that the reason that people were putting on the same line was to save space in textbooks.
Yeah, and that's true. You go fact check that. So maybe that's why I feel so strong, because I came through that time period, and then it's just stuck, right? I don't know, whatever. I guess do what you want. You can do it the right way. You can do it the Emma way. I think maybe the bigger thing is that it definitely makes more sense to put it on separate lines, at least when you're starting to program, because it helps you see, debug your structure, whatever. Once you're an advanced enough programmer, at that point, it's personal preference and probably doesn't matter. That is why I like Python so much for first-time programmers, because it forces that indentation thing, which you would think is such an easy thing, but beginning programmers they have too many things being thrown at them. They don't like it. So it's just one more thing they have to do. So I don't know. So I think that's good. All right, keep trucking here. So threads. Understand the difference between multiple processes and multiple threads, where a process gets its own CPU time and it's sharing that CPU time. Well, not sharing. A process gets its own CPU time, so then gets scheduled separately with the CPU by the operating system. And also a process gets its own local memory space. All right, so that's why we had problems sharing because of the network subsystem had stuff. We had two PCBs trying to share what doesn't look like a pointer, but effectively is a mapped pointer into the network subsystem when we were storing ints for our socket IDs. That's why those things weren't available to us in shared memory. If we were storing like chars or something like that, it would have been fine. Because shared memory does exit out of a PCB just because we were using the network subsystem. We just picked a bad data type to try to share between multiple processes. But in any case, understand the difference between a process and a thread. Threads belong to the parent process. Or you can almost think of it as the parent thread, because that's how most processes are implemented these days, is a single PCB has a single running thread within it. But in any case, when you spawn off multiple threads, they're sharing the CPU time of the parent. But also, and this is where we benefited from the network subsystem thing, they also are sharing the same address space. So we didn't have the problem of exiting out and mapping back with the network subsystem. So that's why the threads fix that. But, you're solving a similar problem, but do understand the difference between those two. I could see myself maybe even asking a question, what's the difference between a process and a thread? Because it does go into a problem-solving approach. Most of the time, in many languages today, you have probably the go-to move is threads. You just do multi-threading because that's what's built into the language. In fact, Java lets you sort of pull off multiple processes, but it's all being scheduled through the JVM, so you don't get it's weird anyways. But let's call it 9 out of 10 times. If you want to do things asynchronously, use threads. Where in C, when you're writing stuff for an operating system, whether it's Windows, we've been using Linux, or any of these things, you get to make that choice. Do I want more CPU time, or do I share the CPU time and need to do things asynchronously? What makes the most sense for the job the problem you're actually solving? Okay, so this was our same solution between our multiple processes and multiple threads, where our shared memory lived within the same memory space for all the threads. Started talking about protecting a resource. This is related to the race condition stuff. So this idea of mutually exclusive access. So this thing called mutex, mutually exclusive. Typically, what we're talking about is one element one entity having access to a resource at one time, but it doesn't have to be that. So we looked at one of the, with semaphores, you can say up to 3 can have access to this. So when we talk about semaphores, I'll get to the slide here shortly, but you should understand what a semaphore is. Effectively, it's a special purpose integer. And the big important part of this is this guy right here, this idea of being atomic, or executing as if it was atomic, which is more of the magic trick on the CPU type thing. So incrementing and decrementing a semaphore is an atomic operation. We can think of it as that. Okay, so understand those concepts, race conditions versus those guys. And this is more I/O stuff. This is just, this won't be on the test in any sort of measurable way. Okay. All right, so this idea of the critical section, this went with the semaphore stuff. So we have this area where we have the bouncer on both sides of the door, and you have the critical section in the middle. That's the code that you want to limit access to. So under, let's call it the common condition, when you're going to allow one resource through, or you're going to allow one entity through the door and give it access to that resource, the critical section is where you have access to that resource. All right, so I could see a question along the lines of, so this would be a non-programming question for the critical section unless I put it into one of the examples, because I probably wouldn't have you write code yourself to make a semaphore, but I might give you an example of code that has a semaphore in it and ask you to identify the critical section or something like that. But generally speaking, I might ask a question like, why is it important to minimize the size of the critical section or something along those lines with the concept of you only want to do your manipulation of the resource you're protecting in the critical section. You don't want to spend too much time doing anything else because that's going to slow down the performance of everything else. Right? So inside the critical section, you should just do logic related to your shared resource. Then you give up that resource and do any additional logic you might work with. All right, so this was our semaphore integer stuff. We talked about message queues, and we did an example with message queues with the chatting stuff too, right? I think I gave you a code example with that. I don't think you did homework with message queues though, did you? So we did have an example of that. I probably would not put code on the exam. Dealing with message queue, I don't know about that. Maybe I would. I wouldn't ask you to write it, but the same thing's true for semaphores and things like that. You certainly should understand the purpose of a message queue, where you effectively have this global queue that that different processes can subscribe to, and they can grab whatever's at the front of the queue to get messages that are passed. All right, so you can almost think of it as like a little bulletin board that any process can put something up there, and then any other process can then read from that queue, and they can keep reading until the queue's empty if they want to, and that allows multiple processes to talk to each other. Probably questions just involving the high level of what a message queue is. I think semaphores are probably more along the lines of what I might give you sample code and ask you to tell me about that. Macros and constants or macros versus constants in C, that could be kind of one of those short answer questions. Benefits of each one. Why might a macro be better? Or you might even say, why aren't macros always better? Would there ever be an example where you would use a constant over a macro? Because what's the difference? When you have a macro, how does the compiler handle that? That's the hash define thing, yeah.
They're replaced at compile time.
So it makes you follow good programming practice, but then turns your code into bad programming practice. So you have a hash define, and then at compile time, it goes through your code, and any place where you have that macro, it just replaces it with the static value, requiring no lookup, no variable lookup. Because at runtime, you already have the value. Where with a constant, constants are resolved at runtime, just like normal variables. So is there an example of when you would ever use a constant over a macro? Go ahead.
If you had a value, you didn't necessarily know what it was going to be when you programmed it, but it wasn't going to change. Because with a constant, I believe you can assign it a value when you first instantiate it.
Yeah, so a constant you can, actually I think you can instantiate a constant without a value, and you can set a value once. That might be true. Otherwise, if it's happening at run, otherwise what you said wouldn't make sense because you can't instantiate it during real time.
Right.
So in order for that to work, you'd have to be able to define an empty constant, be allowed to set it once, and at that point it's locked.
Yeah.
I think you can do that with final values in Java. I think final values let you write once to it.
I know you can, in the constructor, you can write to it.
Yeah, so it's a one and done thing. I think there's also something else with macros where if you have multiple files, and I'm not positive about this, so I probably won't ask it on the exam then, but just more for knowledge. If you have your macros in a header file, I think there's a limitation with compilers, or at least you have to give it some extra flags to make sure that the macros get mapped to all files that the header file uses. There may even be some rules where the hashtag defines must live inside of the .c file, although they definitely exist in header files. But I think there might be some limitations of if you have one header file and you include it in 3 different .c files, there might be some extra stuff you need to do, compiler directives, in order to make sure that your macros get replaced in all 3 files, just because of the way it happens at pre-compiler. So the reason they both exist is there could be some circumstances where a constant is the tool you need, because maybe the generic thing would be that you just don't know what the value is at first. But if you do know the value, macros are always the way to go, because it's fast. The idea of masking, I certainly could ask you something about that, or maybe I can give you some example code and ask you to, I don't know, circle the example of masking in the code or something like that. So understand what masking looks like when you see it using the single vertical bar dealie. Like I said, I might give you a linked list implementation, or tell you to assume there's a linked list implementation and do something with it, some problem solving with it. I wouldn't ask you to write a linked list directly, but it wouldn't be a big deal if I did. I would probably want you to write more individual functions than something that's a collection of functions like that. But you should definitely be comfortable using structs. So you should be able to solve a problem using a struct. I might ask you to, solve some problem that would greatly be benefited by you defining a struct first. I might also give you some structs to work with. Like I might give you a little section on the test that here's some given information, give you a couple of structs and something else or whatever, and then say, write a function that uses these or something like that, solve some problem in terms of these structs or something like that. You should also be able to write your own struct, but I'm just kind of giving you an idea for some of the programming questions. I could give you a question that's maybe a little bit more involved by giving you some starter stuff, tools that you can use for solving that question, whether it's a linked list or something like that. Certainly be able to work with arrays in C. I do like memory stuff, so pointers, working with arrays. My good friend Malik. So make sure you allocate stuff, although as we've seen, I'll probably miss it if you forget to do it. But yeah, whatever. Put the curly brace on its own line. Okay, so this is all our linked list stuff we talked about. All right, so let me go back to the beginning here. These are all history stuff. Probably won't ask you any questions about that. Again, important that you kind of have that in your mind as the thing, but not something I'm going to be testing for. Certainly understand the idea of a context switch. That is something that does come into play for us when we have either multi-threading or certainly multi-processes with fork. I can see asking a question, if I just need an extra question, a filler one, what is context switching, and why is it important that we take into consideration or something like that. Something with the HTTP protocol, I would say would be fair game. We wrote a kind of our own little web server early on, so there could be something related to that. Definitely sockets, kind of the role they play. Somewhere in here, I think I mentioned pipes. I kind of already mentioned that, but I probably won't ask anything about pipes. But the idea of a socket, why you might use one. I might give you a scenario and ask you to explain, which which tool out of 2 or 3 tools or something would be most appropriate to use for this and why, something like that. Along those HTTP things, I could maybe see something from this slide existing, kind of showing that you understand kind of how the internet works. It wouldn't be more than one question, but something with, I don't know about MIME types, but just the idea of making an HTTP request, the HTTP server responding to that request in some way, and ultimately spitting out HTML and JavaScript, showing that you understand what a web server does and how a web server works. Should be an easy question since we wrote one. Not content for here. Along with the HTTP thing, it could be, it would still be in that one question related to that, kind of where REST APIs fall into that that category. We saw a REST API in action with Annie's project. Her Heroku thing had endpoints that were using gets or posts. Twilio also uses a REST API, but she was using an API written in JavaScript for talking to Node's REST API, or talking to Twilio's REST API. So how REST kind of connects to the idea of HTTP and why. Certainly fork, I already mentioned it, just how that works. There could be a coding question with fork where I'd ask you to use it, but more than likely it would kind of find its way maybe in a one of the problems where I said, here's some code, tell me what this does. Although maybe if I was picking between the two, I'd maybe pick threads this time if I was doing something with that. One thing to keep in mind for those style of questions is, if I give you some code and I say, what does this code do? It's fine if you go walk through the code and line by line explain what it does, but what I'm really asking is, as a whole, what problem does this code solve? So I'm not looking for what do these individual 6 lines do. I want to know is, hey, this code finds the biggest number in a list or something like that, not, well, this line creates a new variable and this line prints something to the screen and that kind of stuff. I want you to show me that you understand what 5 or 6 lines, what problem that's ultimately solving. Birds and bees of instructions. The idea of the process control block, there could be a question dealing with that. I mean, I certainly might refer to PCB, but using the acronym, and expect you to know what I'm talking about. So if I'm saying PCB, that should immediately tell you data structure associated with a process. This is not a thread thing. It could, if it's a thread thing, it's a single PCB that houses a bunch of threads. So you should at very least know what a PCB is. I don't know that I would ask you if I asked a question specific about PCBs, it would probably be in the form of context switching. Maybe explain how context switching occurs in terms of a PCB. Remembering the current state of the registers, so that the next time it comes to the CPU, you can unpack that stuff, blah, blah, blah. Maybe a comparison between forks and threads, as I mentioned before, this idea of maybe taking up more CPU time, so very resource intensive. It's not just for the CPU, but you also have to generate a new PCB for each of those, which then becomes problematic. But it does give you the idea of having asynchronous logic. But on the flip side, why is it good? Well, you get more CPU time for your your application and that kind of stuff. Talked about threads as an alternate to fork. This was before we actually used threads, right? We used threads out of necessity, because our socket example wasn't working. But the idea of threads you can kind of think of as being lightweight processes. So they do have a data structure associated with them. It's just less than a PCB, a smaller data structure than that. You should know what IPC stands for. If I use that acronym, inter-process communication, kind of what's the purpose of that, having two processes talk to each other. And more recently, we've seen the idea of kind of inter-thread communication, where we join a thread waiting for it to finish and that kind of stuff. So that allows us to kind of have a similar type of thing between threads, but threads can still benefit from inter-process communication through shared memory and that kind of stuff. But you actually don't even need shared memory for threads because they share the same memory space inside the PCB, right? So you don't even have to use traditional inter-process communication from that perspective. You would still need semaphores or something if you really want to protect a resource. But if you just are sharing some memory, you don't need to move to shared memory, which is a global to the operating system, because you live inside of the same PCB and you have access. If you make a pointer, you're working with the same memory. Probably nothing with cloud computing. Certainly the idea of a blocking instruction versus a non-blocking instruction, synchronous versus asynchronous, that whole idea of why do we need fork or threads to solve problems. Be able to work with strings. You'll probably do a lot with strings and arrays for the programming questions. Obviously understand pointer syntax. Probably be a lot of that. Understand malloc. I wouldn't have you write code that uses sockets, but I might show you code that uses sockets and ask you to tell me what it does. I would expect at least one conversion question. I really like those. So be prepared for that. Practice your conversion question. Okay, hold on. There's no excuse for not getting 100% on a conversion question as a senior or even as a junior at this point. You should be able to do conversion questions. In fact, I might take like retribution. If it's worth 10 points, if you get it right, you get your 10. If you get it wrong, you get minus 50. Take it up with the dean. All right. I think that pretty much covers everything. Questions, comments, concerns, bribes. If you have specific questions about any of this stuff, you want me to review any of it, I will do that on Friday. Then we'll cover a couple of last bit things that probably won't be on the final, but I still want to cover as part of the always a risk of a quiz last day of class, in case you decide to skip on the last day, but choose your own adventure. All right, I will see everybody on Friday.